Assalamualaikum warahmatullahi wabarakatuh. Hi everyone, I am Sakinah Yani from Medan State University, and today I will explain my science project in physics as part of the final International Walisongo competition. This physics project is a vertical spring mass system. In this project, we need materials and tools such as a spiral spring, weight with mass of 1 kg and 2 kg, and a rope. The first step is, of course, we hang the spring on a pole using a rod. After that, we give the spring a load at the end, so that when the load is attached, the spring will stretch a certain distance. So at this point, the mass spring system is in equilibrium, and the net force is zero, where the restoring force acts upward and the load acts downward. Furthermore, the spring that has been paired with the load is pulled at a certain distance and released, so that there will be movement of the spring vertically or the oscillation is occur. The next topic is about the constraints and degrees of freedom of the system. So, how many constraints are there in the system? The constraint contained in this vertical spring mass system is the ability of the spring to stretch to its limit. In this case, the spring is only able to withstand a load of up to 3 or 4 kilograms. And then, how many degrees of freedom are there in the system? The degree of freedom of this vertical spring mass system is 1, or a single degree of freedom, because the system only moves in one coordinate, that is vertically. Next, we will find out the equation that exists in this vertical spring mass system. Based on the result of experiments that have been carried out, it is known that the length of the spring before being given a load is 0.045 meter, and after being given a load of 1 kilogram, the spring stretches to 0.11 meter. This indicates that there has been a change in the length of the spring as far as 0.056 meter. Then, when the spring is given a load of 2 kg, the spring will stretch to 0.15 meter. This also shows that there has been a change in the length of the spring as far as 0.096 meter for a load of 2 kg. With this value, we will obtain spring constant, where to find the value of K using the force value, which is mass multiplied by gravity divided by the value of y, which is the length of the spring when the mass is given minus the length of the initial spring. So we will create a linear equation using the variable of force and delta y. Delta y acts as independent variable or x-axis, and force acts as a dependent variable or y-axis. By using Excel, we will find the value of spring constant is 245.25 Newton per meter. According to the linear equation of the following diagram, the value of the constant K obtained has a low level of accuracy because the mass data used is small. The more mass data, the more accurate the value of the constant K obtained. Consider the following illustration. When the spring is loaded, it will produce a delta L, and when the load is pulled, it changes its length, namely delta L plus y. According to Newton's law and Hooke's law, sigma F is equal to 0, where sigma F is mg minus K delta L, so mg equals to K delta L. Then in the third illustration, the resultant force is equal to the mass times the acceleration and is equal to spring force when it is pulled. So the final equation is ma equals to minus ky. And then next, to determine the equation based on the previous force equation, we get the derivative of p with respect to t, and the quadratic derivative of y with respect to t, with the result is minus omega square y, by the formula omega, which is the root of K over m. After that, the equation y is obtained, namely a sin omega t minus the phase angle. In addition, the existing equation will also obtain equation for the angular velocity, period, velocity, and acceleration of the system. V is the derivative of y with respect to t, equals to omega a cos omega t minus the phase angle, and the acceleration is the square derivative of y with respect to t equals to minus omega square a sin omega t minus the phase angle. And finally, the period equals to 2v divided by omega and equals to 2v times the root of m per k. And the last is the experimental value. Enter it into the question that has been found. The overall result is that omega is equal to 15.66. Amplitude is equal to 0.04 meter. Y value is equal to 0.04 sin 15.66 t. And the V value is equal to 0.63 cosine 15.66 t. The last is the acceleration value is minus 9.81 sin 15.66 t. Okay, that's all about my science project. If there is a mistake, I'm sorry. And don't forget to like my video, and thank you. Wassalamualaikum warahmatullahi wabarakatuh. Bye bye.